In this lesson, we're going to learn how to calculate the amount of the remaining excess reactant. What mass of excess reactant will remain after the reaction of 20 grams of iron and 15 grams of oxygen? In this case, we have to both identify the amount of excess reactant and how much is left over. It's still a limiting reagent problem because we see 20 grams of iron and 15 grams of oxygen, so amounts of two different reactants. But it's not just asking how much can we make, it's trying to figure out how much is left. So we're going to follow the same process initially, but we have to take it a couple more steps to get to our final answer. First, I'm going to put in my molar masses of each substance just so I have those there, and it makes life a little bit easier when I go to set up my problems. The first calculation I'm going to do is assume that iron is limiting. I'm going to start with my 20 grams of iron. Use the molar mass of iron to get from grams to moles. Use the mole to mole ratio to get from moles of iron to moles of Fe2O3. And then use the molar mass of Fe2O3 to get to grams of Fe2O3. And we get 28.6 grams of Fe2O3 that can be produced if iron is the limiting reagent. Next, we're going to assume that oxygen is limiting. We'll start with our 15 grams of oxygen because that's the mass that we're given. We'll use the molar mass to get to moles of oxygen. Use our mole to mole ratio of 2 moles of Fe2O3 to 3 moles of oxygen, and that comes from our balanced chemical equation. And then the molar mass of Fe2O3 to get to 49.9 grams of Fe2O3. And that's based on the assumption that oxygen is limiting. We see that the smaller amount of product is formed when we assume that iron is limiting. Therefore, iron is our limiting reagent. That was our correct assumption. Now we know what the limiting reagent is. We know how much iron oxide we can produce, but now we need to determine how much of the oxygen is going to be left over. And in order to find out how much oxygen is going to be left over, we first need to figure out how much oxygen we need. So we're going to ask a question. How much oxygen is needed to react with 20 grams of iron? Because we know, or we've already shown, that iron is in fact our limiting reagent. We're going to start with our 20 grams of iron and use our molar mass to get to moles of iron. Next, we're going to use our mole to mole ratio between the iron and the oxygen. Remember, we can write mole to mole ratios between any two substances in a reaction. It doesn't always have to be a product and a reactant. We can have two products or two reactants as well. Now we'll use the molar mass of oxygen to get to grams of oxygen, and that is the grams of oxygen needed. So if we have 20 grams of iron, we need 8.59 grams of O2 to react with it completely. But the question is asking us, how much is left over? We always want to go back to the original problem and make sure we're answering the question that's being asked. We know how much oxygen we need. We know how much oxygen we have, so we can figure out how much is left over. So our fourth and final step, we're going to find the excess. We have 15 grams of oxygen. That's what was given in the problem. We determined that we need 8.59 grams of oxygen to react completely with our 20 grams of iron, which is our limiting reagent. And we can subtract that to get 6.4 grams of oxygen in excess. So when this reaction occurs, all the iron is going to be used up. Some of the oxygen will be used up, and we will have 6.4 grams of oxygen left over at the end of the reaction, along with our 28.6 grams of Fe2O3 that we produced.